Here we would like to present to you our development plan to transform a room on the 5th floor of Knowles Building into an iRoom suitable for real estate and construction education. At the offset, let us introduce to you what is the model we are using in planning this development. The model we will be using is called Virtual Design and Construction, also known as VDC. It is a model in which owners, architects, engineers, builders, and other relevant parties can build a facility together in a digital platform. Those parties work together using computer to visualize and to project the facilities to be built, so that they can have a preview to the result after all the construction works, to make sure they are going to build according to what they want and what they need. Different parties also contribute in a data platform by inputting different data about the construction works. For example, the time required by each construction work, the cost of each factor of construction, different design parameter, etc., so that the building process can be carried out smoothly and efficiently. One may ask, why is VDC education important to a university? First, it familiarizes students who are going to take part in the real estate and construction industry with the state-of-the-art construction model, which is very likely to be widely used in the future. The VDC model has been attracting more and more attention from practitioners and scholars worldwide. And with the growing trend of using computer and cloud platform in the industry, it is better to equip students with the knowledge rather than leaving them bare-handed. Another reason why university needs VDC education is that the model gets students to think holistically. By inputting and presenting different parameters in a computer platform, students can understand what are involved in a construction project and what they have omitted in the planning procedure. Also, they can learn how to identify and rectify clashes in design and procedural aspects, so that in the future when they are engaging in construction projects, they can have better planning and design. Of course, the VDC model attracts more and more attention not without reason. The first advantage of VDC at work is that it speeds up the construction process and different parties. One significant feature of VDC is the use of internet platform and cloud system. This feature allows different parties to take part in the project via internet rather than in traditional face-to-face manner. Also, information can be retrieved easily in anywhere at any time by anyone. This advantage is especially significant when the project team consists of members from different places in the world. Another disadvantage is that the model can reduce the chance of incoordination. Again, by presenting the parameters clearly, the builders can identify clashes between building works carrying out at the same time. The designer, by the virtual model, can also know if there are any design conflicts which makes the facility not user-friendly. After describing VDC, here comes to the part of project design. In this part, I will talk about the general objectives of building an iRoom, specific objectives of building an iRoom in our department, reasons of choosing KB526 with respect to conditions, basic design and infrastructures provided and shared achieved architectural and engineering concepts. Why we build an iRoom? iRoom is a room facilitated with electronic enhancement which can cater for the conferencing needs. It helps interaction and information sharing. Inside a room, smartboards are installed. It is a visual aid of model projected. With this projection, we can discuss and avoid conflicts and inconsistency. It also makes processes feasible and achievable during real construction stages. Then, why we build an iRoom in our department? Setting up an iRoom in our department can help to teach students multidiscipline of VDC and BIM. The iRoom can facilitate collaboration of project work of students, which means it can stimulate work of real-life project management team by using smartboards and touchable screens. The iRoom can be used for studio meeting, tutorial, conference, students' bookings, and lectures. Based on these objectives, we choose to incorporate the following design with respect to the conditions of KB526. Why KB526? We consider both the advantages and disadvantages. KB526 has the most regular shape among all rooms on the 5th floor. It makes it convenient to divide the room into several areas. This allows flexible size of each compartment. KB526 can also be formed back into original shape for lecturing purposes. The only disadvantage is that we have to change the framework of KB526. For instance, the position of doors, alignment of walls and floors, because we have to demolish the steps for accommodating electrical wirings. The false ceiling has to be added as well. All these alterations aims at fitting the usage of iRoom and other corresponding building services. Refer to the basic designs and infrastructure provided. The iRoom can be divided into 3 compartments. It will be equipped with an iTable, 2 fixed smartboards, 2 movable smartboards. There are sufficient tables and chairs to cater for 70 students or just 100 chairs for a big lecture. 25 sockets are hidden on the floor with the provision of raised floor. Both touchable iTable and smartboard can be connected to compatible laptops. There are a total of 14 loudspeakers on the false ceiling. Here shows you some photos of the iRoom. The chairs, the tables. You can see that the iRoom are divided into 2 compartments by using partition walls. It can be divided into 3 compartments as well. In our iRoom project, we try to achieve architectural and engineering concepts. Green engineering concept is achieved as the iRoom is in fact energy saving and sustainable. Technical feasibility is considered. Apart from the change of the position of doors, alteration to structural parts is avoided. In our project, building ordinance is compiled, benefit is maximized, and loss is minimized. Now, let me talk about the functional objectives of the iRoom and how these objectives can be achieved. There are 5 functional objectives, namely building services, electricity, flexibility, partition, and technology. A product organization process model, or in short POP model, is used to explain how the goals can be achieved. Here is the product part, the organization part, the process part. In terms of basic building services, adequate lighting will be provided to facilitate different kinds of activities. Indoor air quality and temperature will be maintained at a comfortable level to enhance the performance of the users. Noise outside the iRoom should be prevented from disturbing the lectures, meetings, and discussions. A safe environment is provided for escape in case of a fire, and disabled people can access the iRoom without any obstructions. Referring to the POP model, a building services subcontractor will be employed to install suspended ceiling, lighting system, NVAC system, sound equipment, acoustic treatment, and barrier-free access facilities, while a fire services subcontractor will be responsible for the fire services installation. In terms of electricity, adequate electric sockets will be provided for users to connect their laptops to electricity supply. Positions of the sockets should be convenient for connection but hidden so as not to affect the design of the iRoom. Therefore, sockets are hidden in the raised floor. Referring to the POP model, a building services subcontractor and a flooring subcontractor are responsible for installing the sockets cooperatively. In terms of flexibility, electrical wiring should be hidden and flexible for relocation, entering one of the compartments without causing disturbance to users of other compartments. Also, Chairs and tables should be movable to facilitate different activities. Referring to the POP model, a ceiling and walling subcontractor has to modify the door openings. A floor subcontractor has to build the raised floor for accommodating the wirings, and the purchasing manager is responsible for buying movable chairs and tables. In terms of partition, the iron should be able to be divided into several compartments for carrying out different activities concurrently, while the conversion and restoration process have to be easily carried out. Therefore, movable internal partitioners will be used. Referring to the POP model, a movable partition subcontractor will be employed to construct movable internal partitioners so that the iron can be divided into 3 multi-purpose compartments. In terms of technology, high-tech tools and internet access will be provided. A server capable of central data storage, internal data sharing, and a centralized control system will be installed. Here you can see the iTable and smartboards. Referring to the POP model, a smartboard specialist will be employed to install the smartboards, and an IT specialist subcontractor will be responsible for all other high-tech tools and systems. Since the 5 functional objectives have already been illustrated using the POP model and parts of 3D BIM model, I will talk more on how those 5 functional objectives can be achieved using the Gantt chart and organization chart below. First, I will start with the functional objective of efficient basic building services. What we have to focus is that how this objective can be achieved through careful planning. Planning in terms of time and person in charge is significant to the success of a construction. For example, we can see that installation of different types of building services may be done by different specialists. However, one party's process of work and final finishing product may affect the other party's work or efficiency, etc. In this case, for instance, the installation of fire services may have some correlations with the installations of MVAC system and lighting system. Thus, to achieve the functional objectives of maintaining good building services systems working consistently with conformity, we have decided to arrange these building services and fire services subcontractors to work at the same time period. This is to facilitate better coordination and cooperation of different subcontractors installing different basic systems, as shown in the Gantt chart. Besides, we will put both building services subcontractor and fire services subcontractor under the branch of control of main subcontractor. Besides, we will put both building services subcontractor and fire services subcontractor under the branch of control of main contractor, as shown in the organization chart. Instead of placing the building services contractor at the same level with the main contractor directly under the supervision of our client. The purpose is to enhance coordination too. In order to facilitate future usage during occupational period and potential maintenance of the electrical wiring system within the raised floor, we have the following arrangements. The work of the flooring subcontractor will be started as soon as the building services subcontractor has fixed all the electrical wires, as indicated in the Gantt chart. This is to ensure that there will be enough space for future fixing or maintenance. Also, this is to avoid too much dust or various particles from accumulating on the electrical wires, which will in turn affect the performance of the electrical wiring system. Once again, as shown in the organization chart, both the building services subcontractor and the flooring subcontractor are under the supervision of the main contractor for higher efficiency of work. Next, talking about the functional objective of maintaining flexibility and providing partitions. Different measures have been planned, and some may have already been mentioned in the previous part using the POP model and some parts of the 3D BIM model. These include the installation of tracks for partitions and also the alteration to the walls to make new door entrances. However, from the Gantt chart, it is noted that some of these jobs cannot be done in parallel with other jobs due to structural safety issues, like in the case of partition tracks and door entrances. Lastly, for functional objective of technology, we have allowed the installation of Internet and cloud system to be done during the same period of the time. This is to help facilitating each other's work. The installation of computers and iTable will also be done in parallel to ensure the coordination of all systems mentioned in the Gantt chart. Now, I'm going to talk about the 5 business purposes of the models. First, VDC strategy can enable companies to achieve significant breakthrough objectives. Some organizations now find significant competitive advantage from their facilities or their timelines of developing new facilities. The project can be completed in drastically less time while preserving or improving quality, schedule, and cost performance. Second, different stakeholders have different responsibilities. VDC improves the coordination and exchange of information between project stakeholders. This results in effective and quick solutions to bottlenecks that may occur during a project and that could prove to be costly during the construction phase. Third, stakeholders can collaborate by sharing visualizations. The model strongly emphasizes the use of models that can be described to and evaluated by multiple stakeholders. It ensures the integration, follow-up, and management of all 3D models within a central model. The 4-dimension links construction planning with the element of time. 4D models allow our customers to visualize and optimize project phasing and construction sequencing. Fourth, VDC enables better project management. Once started, projects always face severe time, cost, and quality constraints. The integrated focus on all the aspects that can be managed, project, organization, and process, at least enables projects to find integrated solutions to complex interrelated problems. Finally, VDC helps clash detection. VDC links all the models and analyzes them to detect clashes. It helps resolve problems at the design phase rather than at the construction phase when rework is extremely costly. There are some potential risks in the project. For example, since new door openings are close to partition walls, and the installation of doors and partition walls commences on the same day, space may not be enough to carry out the works concurrently and work schedule may be affected. From the process chart of the POP model and the Gantt chart, we find the information of relevant works. For example, from the POP model, renovation of existing ceiling and wall takes 9 days. Construction of internal partition takes 4 days. From the Gantt chart, we can see that the installation of doors and partition wall tracks start on the same day. Both contractors and client have to take some risk on this task. The wall and ceiling subcontractor and the partition wall subcontractor may fail to finish their work on time, which affects other trades. Then they have to pay damages to the client. On the other hand, the client has the risk that the overall schedule may be affected and the construction may fail to complete on time. Then IREM subsidies cannot be provided at the beginning of the semester. From the organization chart, the main contractor is on top of the related subcontractors. Therefore, the main contractor has to provide coordination and instruction to subcontractors so as to avoid them carrying out the work at the same area. The decision maker of the project includes the client, the project manager. The client is responsible to specify his requirements and the budget. The project manager is responsible to manage the progress and cohesion of different trades of work to ensure building quality and to resolve issues. From the organization chart, The two parties are on the top of the contractual arrangement. So, why do we have to do the modeling and analysis to present to the client? Through these models, our clients can know in detail the possible and proposed quality that can be achieved in terms of technology, durability, and convenience. Also, our clients would like to know the whole life cost, including the future predicted repairing cost. Schedule and risk are important too, since this will affect the smoothness of the construction process. In this project, I'm introduced to 3DC modeling. At the beginning, I'm not sure whether I could handle it or not because I think it is quite complicated. However, after 3 weeks' time, I learned its basic components and how it can be used to enhance the quality of a construction project. I think it is worth spending time on learning the software of VDC modeling such as Google Sketch, Microsoft Project Professional, and other more advanced software because this can enhance my competitiveness. Although it is not common to use VDC modeling in Hong Kong now, I think it will become more popular soon because applying the VDC modeling properly can help to save cost and time of a construction project, which can make the project more cost-effective and profitable. To conclude, I would like to thank all my groupmates for their contribution and hard work, which can make this mission possible. It was a memorable experience to work with them in the library for the whole day. This is the first time that I know about virtual design and construction. It gives me a new insight on how to organize a group of project teams in a construction project using computer technology. It is also my first time to come across iRoom. It is a totally new concept to me. It gives me new perspective on communication within project teams in a construction project. The communication in a meeting becomes more intelligent and interactive. Every party in the project can actively participate in giving new ideas to the design. Throughout this project, our group has discussion in an iRoom in Hong Kong U and tried the smart board inside the iRoom. We all find this technology helpful to our interaction. It was a good experience to us. In this project, I tried many new software such as Google SketchUp and Plexi. It is very interesting and rewarding to learn different computer softwares. All in all, we learned VDC, which is a new concept to me. This gives me a fruitful experience and insight on the construction industry.
In this scenario, I learned a lot concerning construction project management, especially how VDC, virtual design and construction, and building information modeling helps construction management scheduling. Communication and information sharing is now not quite efficient. With technology and VDC make instant information sharing possible, which means a lot of resource and human labor can be saved in the future. It can be foreseen that the time used for our construction project can be greatly shortened. In this scenario, I learned different types of software. It is quite good to learn something that helps presentation and project scheduling. Throughout the iRoom project, we learn POP models, 4D models, Gantt chart, etc. Those useful tools help a lot in the organization of a project. In iRoom project, we are consultants. We have to take careful consideration of each details when building an iRoom. It trains us to be familiar with the sequence of a construction project and how each building element affects each other. At last, I really enjoyed the day I spent with my groupmate when we finished this task. Work and play together. This is our group, Studio Group 7.
This video project, I focus on sketching 3D model, making 4D model, and its animation. I spent so much time on these models in my computer. It is quite a different experience to manage and contribute to our group project team. I learned POP model, VDC model, and ICE. I also learned the 4D virtual builders, Microsoft Project, and Pepsi. I further mastered with the use of Google SketchUp. We found that the 4D virtual builder, although can be a powerful software, still not so suitable for indoor project. Moreover, the function of free Google SketchUp is limited. We solve different kind of technical and design problem together. Although it's quite successful to use SketchUp and make our movie finally, there's still lots of space for improvement. This month is definitely not an easy task. It is so lucky to have my caring groupmates to achieve this goal together.
In this scenario, we are exposed to many new technologies and approaches, like the POP model, iRoom, the smartboard, to name but a few. By all these, we are somehow forced to use new softwares, like the Microsoft projects and Google SketchUp, which we have never been using before. However, what I think the most important is always experience. Take for example, if we have never been to an iRoom in the library, we can never know how the iRoom works, how the smartboard works, or what are the shortcomings of an iRoom. Take for another example, if we have never been going through a renovation project, we can never know what are the possible conflicts which will occur when one or more construction works take place at the same time, like we are facing in this scenario. Only by experience can we design a well-equipped and a user-friendly iRoom and to make a good schedule so that the renovation works take place smoothly. I wish to thank all my groupmates for creating this experience with me with great endeavor. And I'm quite sure with this experience, we can master the virtual design and construction model in no effort in the future. After all, the essence of studio projects is always experience.
In this project, I've learned a lot on project management. It is quite interesting as I have never imagined that the 3D BIM model can be combined with the schedule of Gantt chart. I'm amazed that a 4D model with the element of time can be done and the whole process of construction from the start to the end can be shown vividly in the form of video. Besides, I think the use of POP model makes a systematic approach which facilitates the development of level of details. If we are asked to build a model, we may just start from anywhere as we like and continue at any point without any organization. However, this will lead to inconsistencies of different parts. Meetings are important to allow us to compromise on important details from different points of views. Gantt chart is also another thing that I'm inspired by. The use of Gantt chart is not just a timeline or a table of sequences of processes. Processes in the Gantt chart can be subsequently adjusted if one has changed. Parallel processes and independent processes are also implicated, so I did learn something from this project.